Okay, and we are back in the evening. The sun's over there now. So, microphone died. Or wait, what camera microphone? Microphone died. Camera got full of storage. Huh. Oh my goodness. Well, anyway, after doing the cross section, going all the way across, and what I was sort of chatting about here silently, I'll add that video, was plotting. Was trying to, plotting the XY axes, X being the steps and Y being the depth from horizontal. And we're really going to do the same thing with a longitudinal profile. So starting in the upper right-hand side of that graph paper, if we were looking this way, we're just going to turn this way now and graph in this direction. So south on this side of the paper and north on this side of the paper. And I'm going to start over there by that boulder, and I'm in the middle kind of the river, and I'm just going to walk one step at a time again, and we will record these in the tenths of meters. So right now I'm showing 721.2 meters, and we will record that in tenths per box. So every box down is 0.1. Now, then I want to point out that this is going to be very vertically exaggerated because our this direction is 1 meter, but then the Y direction is instead of going 1 meter, we're going 1/10 of a meter, just 10 centimeters, and that's going to overall exaggerate the vertical axis. So it'll be about 10 times exaggerated at that rate. Okay, so what the point here is, I'm sure we're all familiar with, in the watershed or in water in general, in the water cycle, hydrologic cycle, that rain or water in a river is flowing downhill. And in fact, I think even this stream is such a high gradient right here that you can see it's uphill up here on this side, and it's downhill towards this side. But we're actually going to measure that. Rather than just looking at that, we're going to measure that in tenths of meters. Okay, so let's get started. And I hope my sound is working well. Okay, you can also longitudinal profile by walking along the bank of the river. Okay, but I like to be out in the stream, so we're just going to do it out here in the stream, starting. Here. I'm a little lower. We're at 719.5 meters. So I'll call these out in the digits point blank. Okay. Okay, first step, 19.5, 19.3, 19.3. Whew. Oh. Okay, remember this, the GPS, they're not very good vertical accuracy because of the satellites, and they're pretty good at horizontal accuracy, but vertical accuracy not so great. So I'm at 19.0. Just one step. 19.0. 18.9. 18.7, doubt that's true. Okay, 19.7, 19.5, they kind of toggle a little bit, right, go up and down. 19.3, 19.3, one more step. We can go a couple more steps, I'm sure you got more on your paper. 19.2, 19.2, 19.2, 19.0. I was saying 19, we mean 18. Ugh. Okay. Now 18 even, and 17.9 steps. Woo! Just demonstrated here, besides me almost falling in the water, was that even though the stream bed does feel relatively flat with some ups and downs of rocks, there overall is a drop in gradient from there. And I want to reiterate that my GPS isn't the best for vertical accuracy. So if we really wanted to do this, we would do a different kind of surveying line from horizontal, like we did the cross-section line earlier. But anyhow, I think that is a really good measurement using a digital GPS device, and gives us, and hopefully if you're graphing that along, a nice stream profile. Good. Come on, Twitch.